bayan ang pambansang awit ng Pilipinas.
A prayer for teachers. Giver of all wisdom and greatest of all teachers, look upon our teachers with love. Grant them the resolve to nurture our eager minds and to never give up on us who fall behind. Bless their hearts, for they rejoice when we succeed, and encourage us when we fail. Endow them with gentle patience, for the path of learning is never easy. Kindle a spirit of passion in them. It is the flame that ignites the love of learning in us. Help them see the potential in each student. Their belief in us means much more than the grade we make. Instill in them a commitment to keep on learning. It shows us to not fear new knowledge and experiences. Inspire them to touch the future. They influence how big a dream we dream for ourselves. Bless our teachers who have come before, for their work endures to this day. Let the light of your example shine upon all teachers, to build up with their words, to love with their mind, to share with their heart. Amen.
Good morning, magandang buhay, DepEd Bataan teachers. Hello everyone, especially to all grade 5 science teachers, and welcome to Quarter 4 Division Webinar Series on Science Content and Teaching Strategies of the Most Essential Learning Competencies. This webinar series made possible because of the combined efforts of the Schools Division Office of Bataan, headed by our very own OIC Schools Division Superintendent, Dr. Roland M. Pronda, OIC Assistant School Division Superintendent, William Roderick Palurin, and all the supervisors, principals, department head teachers, and most of all, our dear teachers who are very curious and very science enthusiasts. And before we begin, let us first state the purpose of this webinar series. We have two objectives. The first one is to enhance the knowledge and pedagogical skills of science teacher in teaching science from grade 3 to grade 12. The second one is to capacitate all science teachers in the content and teaching strategies in the context of the most essential learning competencies for Quarter 4 in using various platforms and modalities that teaching and learning made available at all levels. To begin, let us hear an inspiring welcome remark from our diligent and very passionate Education Program Supervisor of Science, no other than Dr. Edwin Riel Vermilio. Isang malikhaing umaga, Dr. Edwin.
Magandang buhay po sa lahat. Welcome to the last wave and leg of our division webinar series on science content and teaching strategies in the context of the most essential learning competencies for the fourth quarter. Sabi po ni Henry Ford, coming together is a beginning, keeping together is progress, working together is success. And I believe that this highlights the importance of working together in teams for science department from first to fourth quarter of its activities. With this, I would like to personally take this opportunity to express our sincerest gratitude for the success of all our science webinar series. To our school's division superintendent, Dr. Roland M. Fronda, to our assistant schools division superintendent, Sir William Roderick R. Falurin, words can neither qualify nor quantify how helpful your guidance and advice has been. We are forever grateful for your support sa Science Department. We continuously learning from your examples because your leadership is not just about titles or positions, it's about one life influencing another. Thank you po, Sir Roland and Sir William. To our Curriculum Implementation Division Chief, Dr. Milagros M. Peñaflor, thank you for your trust and confidence. Your support and guidance have been instrumental in helping us to provide quality science curriculum instruction by enhancing the content knowledge and pedagogical skills of our science teachers, including alternative learning system from grades 3 to 12. To our public school district supervisors, science department heads and coordinators, and our elementary school principal coordinators, our sincerest thanks for selfless support in all our endeavor. Your dedication, compassion, skill, and professionalism will allow us to get through all the activities with flying colors, and we are all indebted to you. We appreciate your sacrifices to be at work. We want you to know that your actions are seen and appreciated. To our team leader and assistant leaders per grade level who had been working countless hours to make sure that everything is okay. Sabi po ni Mother Teresa, God does not command us to do great things. God commands us to do little things with great love. Not all of us can do great things, but we can do small things with great love. Maraming salamat po sa pagmamahal. Amidst the challenges, I am also very grateful to have our intelligent, strong, competent, and brave resource speakers who took the challenge as learning facilitators. Thank you for great performance, dedication, and expertise in delivering quality instruction to the teachers and learners of the SDO Bataan. Of course, special thanks to the members of the program management team in charge for online platform, program design, Google Forms, and our moderators for the hard work and for silently working behind the scene just to make sure that we have tools and resources available. We value all your dedication to keep us up and running. Your efforts are truly appreciated. To our science teachers, we hope that the trainings we have provided will help contribute improve students' learning outcome, develop strategies and approaches, and encourage quality implementation of science curriculum and implementation. From the first until this fourth quarter webinar series, your individual commitment to a group effort is what makes a science department. Maraming salamat po sa lahat. God bless us all.
Thank you so much, Dr. Edwin Riel Vermilio. Now, to give us another motivating welcome remark, let us hear it from our very benevolent Curriculum Implementation Division Chief, Dr. Milagros M. Peñaflor. Good morning po, Ma'am Mila.
Today is your last among the 4 webinar series of this kind in science. I am glad that you all were able to make it. Congratulations to everyone, my dear science teachers, department head, principal coordinators, and to Sir Edwin Bermilio for the untiring efforts in bringing a quality science instruction to our young people amidst the challenges. We are now on the fourth quarter. It's like that we are ending the school year, but most of the wrapping up activities will be in this last quarter. The remediation, the catching up activities, plus of course, the readiness of our learners for the year-end assessment. Let us see to it that all competencies reflected in the most essential learning competencies are learned by our students. The provincial government, in line with the development of the Human Index, would like to measure how our schools perform, how our learners fare, considering the implementation of the learning continuity plan of our schools. I know that it is really hard to cope up with the many challenges, but I have seen how you did it with so many times with the issues and concerns in science. The challenges lies not only with our learners having the competencies, but how we make them critical and creative thinkers. Today's session hopes to deliver both, as our competent speakers dwell on interesting topics, putting premium on the plight of our teachers in teaching the skills, how this could be a ready hand for teaching lifelong learning skills in science. Thank you for everyone's participation in this webinar. Thank you for your resiliency in pushing through up to this last quarter. Thank you for keeping up with your promises para sa bata, para sa bayan. Happy day, happy learning, and God bless us all.
We are grateful to have you this morning, Ma'am Mila, and thank you for the words of erudition and support to our students and teachers. Now, to give us another inspiring message, let us all welcome our kind-hearted, hardworking, and very efficient Schools Division Superintendent, Dr. Roland M. Fronda. Isang malikhaing araw, Sir Roland.
Good day to all the participants in the webinar series on science content and teaching strategies in the context of most essential learning competencies for the fourth quarter for grades 3 to 12 in SDO Bataan. We are nearly 1 month to go before the closing of school year 2021. And we have hurdled, we have surpassed, we are survivors. This event likewise culminates the webinar which the division have initiated from the first quarter up to the last quarter. And I am certain that what we have experienced from the time we started this uncertain and ambiguous journey, it has taught us a lot of lessons how to cope with all these challenges. In our present system and practices in education, particularly in these trying times of uncertainty, many of us would surmise that our education systems are not well aligned with the overall goal of learning. Other goals can detract from, and in some cases, compete with efforts to improve learning outcomes. We could also infer that the elements of an education system are often incompatible or incoherent. For example, our government funding allocation sometimes fail to provide the resources schools need to improve learning, and even the school funding is available. The rules governing its use often leave little flexibility for schools to use it in ways tailored to specific needs of students. What we can do is to become resilient. No, it's resiliency is actually the byword of the pandemic. No, to promote resiliency, no, as science teachers, no, we must consider our strengths and our assets in education communities and systems to support our students in making sense of the adversity they experience. I know that it's not only the students who are experiencing adversity, but also our teachers, our school administrators. We should find the very purpose in education and develop the needed skills and competencies. We need to upskill ourselves as well as teachers. Your collective participation in this kind of academic exercise can propel our mutual support and commitment to learning, because protection and well-being of our students, our staff, and our families that are affected by this great educational challenge is paramount. Well, to put emphasis, resilience matters because not only is learning and school success possible in spite of adversity, education can also be the vehicle to overcome the adversity. To Dr. Peñaflor, our CID chief, to Dr. Bermilio, and to all the participants, thank you very much for sharing to us your precious time to actively participate in this kind of activity, this half-day activity. I believe this will end until the Friday of this week. I hope all your sharings of experiences would give us feedback to calibrate and redirect our compass what to prioritize, because we value your observation, we value your inputs and recommendation to better improve our service. We want to make sense and find our purpose that in turn will allow us to make meaningful and positive decisions as we mold heroes in Bataan. Magandang araw po sa ating lahat. Pagpalain tayo ng dakilang Diyos at patuloy po kayong mag-ingat.
Thank you very much, and we are blessed to have you this morning, Dr. Roland. It is a big prestige for me to introduce our facilitator. To escalate our understanding on the content topic under the most essential learning competencies, weathering and soil erosion shape the Earth's surface and affects living things and the environment. She is a teacher tree from Balon Elementary School. Let us all listen and enlighten to the discussion of Miss Evelyn V. Gastalia. Good morning, Ma'am Evelyn.
Good morning, fellow educators. Welcome to the Division webinar series on science content and teaching strategies in the context of the most essential learning competencies for the fourth quarter. I am Evelyn B. Gastalia, your facilitator for today from Balon Elementary School, Mariveles District. In this session, under the content standards, we are going to talk about weathering and soil erosion shape the Earth's surface and affect living things and the environment. Under the most essential learning competencies, describe how rocks turn into soil. Investigate the extent of soil erosion in the community and its effect on living things and the environment. The surface of the land that we see today is different compared to how they were before, millions years ago. Steep mountains and hills change because of erosion. The soil coming from mountains and hills is brought down to the lower areas by water. Surfaces of low areas also change. If you live near a river, you might have seen how some parts of riverbanks disappear after heavy rain. Consequently, weathering has positive and negative effect on our lives. Weathering helps us with some important materials we use in fulfilling our need for shelter, like sand, cement, and some valuable stones. On the other hand, it also has adverse effects. To name one example, high-risk landslides happens when people are quarrying excessively. These changes, brought about by weathering and soil erosion, are important consideration for sustainable development we all aim for our home planet, leaving us the responsibility as educators to teach younger generations the essence of knowing the facts and also instill the right values in taking care these entrusted richness to us on this planet we live. So fellow educators, let us deepen our understanding of this topic. Now, let us have a short mind activity. I want you to think of forces of nature affecting the changes in the landform shown on the left screen, compared to the resulting landform after some years pass by. Let's start with after 100 years. After 10,000 years. And after 2 million years. Think about it. Time's up. If you thought of wind, water, the case of some dead animals, you've got a good background knowledge on our topic. Congratulations! How about other than forces from nature? Again, let's think about it. Time's up. You might think of man-made development-related activities. And yes, you got it right again. Excellent! How about this one? We might think first only forces from nature affects this example. Correct. There are forces of nature affecting this example. But what is happening today? Man is not contented as they were before. Continuous exploration under the ocean is evident. In our nearby country, for example, China, is doing exploration for development or so underneath the West Philippine Sea, which may cause changes in the landforms there, either positively or negatively. Now let us witness different rock formations coming from nature and other man-made structures using rocks. Look how amazing those man-made structures out of different rocks are created, considering its valuable contribution for our everyday comfort. Those are just some of the amazing results of weathering and soil erosion involving human activities, which have positive effects in the development. Still, it is accompanied by some negative effects when done excessively. Now, all of those amazing things we saw undergone the unique process called weathering. And what is weathering? In simple definition, it is breaking down of rocks in smaller pieces due to agents of weathering. This is divided into two types. Number 1, mechanical weathering. Number 2, chemical weathering. Mechanical weathering occurs when rocks break down into pieces due to physical forces without changing the mineral composition of the rocks, while chemical weathering happens when rocks break down due to reaction with water, carbon dioxide, oxygen, and organic acids. This process forms new substances from the minerals of rocks. Here are the agents of mechanical weathering. Number 1, abrasive agents. Wind, running water, or ice sometimes carries rock fragments or sand grains that act like sandpaper. Whenever they strike the surfaces of the rocks, this causes wearing away of rocks. due to scrubbing, and this is called abrasion. Number 2. Water. Water seeps in through some openings in the surfaces of rocks. When water freezes, it expands. When the water is exposed to hot temperature, it contracts. The continued expansion and contraction enlarges these openings and eventually break the rocks into pieces. Number 3. Temperature. The sun rays heat up the rocks and rain cool them down. The exposure to changing temperatures causes stress on the outer surfaces of the rocks and eventually breaks the rocks into pieces. Number 4. Plants. As the roots of plant grows, they may enter fractures in rocks and exert pressure on these spaces. Continuous pressure eventually causes the rocks to break apart. The process is called root wedging. Number 5. Animals. Animals that dig out the ground, such as moles and rabbits, move deeply buried rocks to the surface where they can be affected by physical and chemical processes. Buried rocks layer may also be exposed and left weak to water and acid intrusion. And number 6. Human. Human activities like quarrying breaks down large rocks easily. Excessive mining activities can trigger landslides. A simple kicking of rocks can cause weathering already. Some building developers use equipment such as bulldozer and jackhammer to flatten hills that break a big pile of rocks. Mining companies extract stones and rocks from a quarry. They throw dynamites and other explosives on quarry sites to turn huge rocks into gravel or smaller stones. This activity may cause landslides. How about the agents of chemical weathering? Here are some of those. Number 1. Oxygen. When combined with iron, produce iron oxide or rust. This type of chemical reaction is called oxidation. Rocks with iron-rich materials are easily oxidized, thus producing rusty colors on their surfaces. Rust softens the rocks, and when this happens, it results in chemical weathering of the rock. Number 2. Carbon dioxide. When carbon dioxide from the atmosphere dissolves in rainwater, carbonic acid is formed. Precipitation that contains carbonic acid reacts with the minerals in rocks in a process called carbonation. Carbonic acid can easily weather marble and limestones. Water. Water weathers rock either by dissolving its minerals to form solution or combining directly with some minerals to have new ones. Both processes occur due to chemical reaction called hydration and hydrolysis. Plants and animals. A number of plants and animals may create chemical weathering through the release of acidic compounds. The most common form is the release of acids by plants, which break aluminum and iron-rich compounds in soils beneath them. Decaying remains of dead plants and animals in soil may also form organic acids, which, when dissolved in water, affect surrounding rocks and soil. After learning how rocks break down into smaller pieces by means of mechanical and chemical weathering, let us go to the next possible event that will happen after weathering, and that is erosion. How does soil erosion happen? When rocks break into smaller pieces, it does not stay in one place. Some rock fragments become part of the soil, while other rock fragments can transfer from one place to another. We call it sediments. They are moved by agents of erosion. Sediments are easily transported and carried to different places. This natural phenomenon sometimes causes harm to man and the community, especially if it happens unexpectedly. Like weathering, there are agents or causes of soil erosion. These are: Number 1. Water. As water flows, it transports rock and soil particles from one place to another. The speed of flowing water affects the rate of erosion. As water aids erosion, its color changes depending on the rock's color and the soil particles that it carries. Number 2, wind. As the wind blows, it carries light particles of rocks and soil, transporting and depositing them into another place. Strong wind transports the soil particles to a distant place. Wind erosion can take place in any area where the soil is not compacted. Number 3, animals. When burrowing animals like moles and rabbits dig the ground, some rock and soil particles stick to their body. As they move from one place to another, they carry such particles too. Number 4, human. Humans also have a chief contribution to the rate of soil erosion in the environment. Just like animals, whenever we walk, the soil clings to our shoes, so the dust gets transported from one place to another. Human activities like gardening can also cause erosion, since soil moves as we dig the ground. Aside from these agents, some human activities can also cause soil erosion. Examples of these are mining and road construction. Since soil erosion is a continuous process that gradually changes the natural environment over time, meaning to say from generations to generations, we contribute to the effects of soil erosion in the community. With the simple human activities like quarrying and mining, and other activities for development purposes. This is a perfect opportunity to instill sense of responsibility to our learners about their invaluable contributions to the effects of it. We have to emphasize to them that the effects of soil erosion affects not only the present inhabitants of Earth, but also the future successors of it. Now here are some of the human activities causing soil erosion. How do these activities lead to harmful effects of soil erosion in the community? Cutting down of trees. Trees and plants in the soil lessen the amount of soil being eroded during rainy days. When trees are cut down, soil will be loosened and can easily be moved by water. Mining. Loose soil in hilly or mountainous area where mining is excessive, when moved by strong and fast water, can lead to landslide. In every natural process here on Earth, like soil erosion, affects both living things and non-living things. It affects the ecosystem. And with that, let us be reminded, together with our learners, the good effects and bad effects of soil erosion. The good effects are, it can shape landforms. It can result to soil formation. It can transform large masses of soil to wonders of nature. However, it can destroy large masses of land. Too much soil erosion makes the soil unable to hold or absorb water that results to its dryness. It can change the appearance of the mountain. Landslides may occur. Nothing holds the mineral tightly. We may not control the natural occurrence of erosion, especially so when nature is involved. But let us learn from the experience of our kababayans when they had it in Pampanga during the Mount Pinatubo eruption in June 1991. How did they survive and rise stronger than before after that devastating event? Livelihood of the people there depended on soil for their crops. Mount Pinatubo eruption greatly affected the livelihood in the community. Lahar were mixed with their topsoil, resulting into infertility of the soil. Now, their living does not depend on soil and crops anymore. Lahar is Pampanga's biggest source of revenue. See how they were able to rise again after that catastrophe they had encountered. And we can actually include this for values formation among our learners, which is timely if we could relate it to the current situation we are all going through right now. Alright, so here are some of other effects of soil erosion on landforms and living things. Human activities such as deforestation, illegal logging, overgrazing, and quarrying aggravate the effect of soil erosion in the environment. Excessive deforestation, mining, and conversion of mountains to residential or commercial lands trigger erosion that can be destructive to the environment. Once the topsoil is gone, the nutrients for plants will be carried away as well. Sediments that are washed away by water can clog irrigation systems and can further inhibit the plant's water supply. Less food production due to infertility of the soil, affecting animals and humans, since plants are their main source of food and nutrients. Erosion brought about by water can wash mine tailings to nearby bodies of water and pollute them. So, fellow educators, see how these things will significantly affect us humans if we do not deal with it seriously. This is a great reminder that it is included in the most essential learning competencies, for it is essential indeed for our learners who will be the next successor and caretaker of our beloved planet. This will now bring us to the last discussion regarding soil erosion and some practices that can help control it and its harmful effects. We cannot prevent some of the soil erosion since these are naturally occurring in the environment. So here are some practices that can help us control soil erosion and its harmful effects. Let us choose natural vegetation, the simplest way and natural way of controlling soil erosion. It is allowing plants and animals to grow naturally without human interference. Next, contour flowing. It is planting on mountainsides, following the contours or curves of the land instead of planting crops up and down the slope. This is to slow down the flow of water and the soil that it carries. Next, strip cropping. This method involves alternately planting crops in strips. Terracing. It involves planting on terraces or steps built on the slopes of mountainsides. Crop rotation. It refers to planting crops in different spots each year. Riprap. It refers to building ripraps or chunks of stone or rocks arranged on edge of a slope. To end our discussion, I want us all to have a reflection on this. Earth provides enough to satisfy every man's needs, but not every man's greed. Once again, good morning. Thank you for listening. God bless us all and have a nice day ahead.
Welcome back. Before we proceed with our next speaker, shout out muna po tayo sa lahat ng teachers from Mariveles District, especially to all teachers of Kapkabin Elementary School, Lucanin Elementary School, Balon Elementary School, and Agles Elementary School. Thank you very much, Ma'am Evelyn, for a very informative discussion and sharing your expertise and knowledge with us. Our next speaker to defend the content topic about constellation and the information derived from their location in the sky, different star patterns throughout the year, is a grade 9 and 10 science teacher of Saysayin Elementary School. She is a friend of mine and a very approachable teacher, no other than Ma'am Nova C. Resente. Good morning, Ma'am Nova.
Good day, everyone. Welcome to the last quarter of our division webinar series in Science Content and Teaching Strategies, in the context of the most essential learning competencies for grade 5 learners. For our topic, different star patterns throughout the year. For the most essential learning competency, identify star patterns that can be seen at particular time of the year. For our objective, let us explain why some constellations are not seen at certain months. Observers in ancient time also imagined group of stars that form pictures of animals, objects, and people. These imaginary groups of stars are called constellations. Constellation, a group of stars forming a recognizable pattern that is traditionally named after its apparent form or identified with a mythological figures. The word constellation comes from the late Latin term constellatio, which can be translated as a set of stars. It came into use in Middle English during the 14th century. These terms generally referred to a recognizable pattern of stars whose appearance is associated with mythological characters or creatures, earthbound animals, or objects. A more modern astronomical sense of the term constellation denotes one of the 88 International Astronomical Union designated constellation recognized today. Modern astronomers divide the sky into 88 constellations with defined boundaries. A constellation is an area in the celestial sphere in which a group of visible stars form a perceived outline or pattern, typically representing an animal, mythological person or creature, or an inanimate object. In astronomy, circumpolar constellation that never sets below the horizon as viewed from a location on Earth. Due to Earth's rotation and axial tilt with respect to the Sun, the stars and constellation can be divided into categories. Those stars and constellations that never rise or set are called circumpolar. The rest are divided into seasonal stars and constellations. The stars and constellations that are circumpolar depends on the observer's latitude. In the northern hemisphere, certain stars and constellations will always be visible in the northern circumpolar sky. The same holds true in the southern hemisphere, where certain stars and constellations will always be visible in the southern circumpolar sky. The celestial North Pole, currently marked by Polaris, is less than 1 degree away. Always has an azimuth equal to 0. The pole's altitude for a given latitude is fixed, and its value is given by the following formula. Altitude is equal to 90 degrees minus latitude. All stars with a declination less than altitude are not circumpolar. As viewed from the North Pole, all fully visible constellations north of the celestial equator are circumpolar, and likewise for constellations south of the celestial equator as viewed from the South Pole. As viewed from the equator, there are no circumpolar constellations. As viewed from the mid-northern latitude, 40 to 50 degrees circumpolar constellation may include Ursa Major, Ursa Minor, Cepheus, and Cassiopeia. Cassiopeia is a large constellation in the northern sky, after Cassiopeia in Greek mythology. Cassiopeia is the 25th largest constellation in the night sky, occupying an area of 598 square degrees. It lies in the first quadrant of the northern hemisphere and can be seen at latitudes between positive 90 degrees and negative 20 degrees. Nicknamed the W constellation, it is easily recognized for the prominent W asterism formed by its 5 brightest stars. The neighboring constellations of Cassiopeia are Andromeda, Camelopardalis, Cepheus, Lacerta, and Perseus. Cassiopeia has 3 stars with known planets and contains 2 Messier objects, M103 and M52. The brightest star in the constellation is Alpha Cassiopeiae. Cepheus. Cepheus is a constellation lies in the northern hemisphere. It is the 27th largest constellation in the night sky, occupying an area of 588 square degrees. It is located in the 4th quadrant of the northern hemisphere and can be seen at latitudes between positive 90 degrees and negative 10 degrees. The neighboring constellations are Camelopardalis, Cassiopeia, Cygnus, Draco, Lacerta, and Ursa Minor. The brightest star in the constellation is Alderamin, Alpha Cepae. The constellation contains four formally named stars. The stars named approved by the International Astronomical Union are Alderamin, Alpherk, Array, and Kurha. Draco. Draco is a constellation in the far northern sky. Its name in Latin for dragon. It makes it the 8th largest constellation in the night sky. The constellation Draco is a northern circumpolar constellation that is visible at latitude between 90 degrees and negative 15 degrees. It is a large constellation covering 1,083 square degrees of the sky. It lies in the 3rd quadrant of the northern. Ursa Minor. Ursa Minor, also known as the Little Bear, is a constellation in the northern sky. Like the Great Bear, the tail of the Little Bear may also be seen as the handle of ladle, hence the North American name, Little Dipper, 7 stars with 4 in its bowl like its partner, the Big Dipper. It is visible all night as it rotates around the North Celestial Pole. It is a small constellation covering an area of 256 square degrees. It is located in the 3rd quadrant of the northern hemisphere and can be seen at latitude between positive 90 degrees and negative 10 degrees. The neighboring constellations are Camelopardalis, Cepheus, and Draco. It ranks 56 in size among the 88 constellations in the night sky. It is famous for a group of stars known as the Little Dipper and for Polaris, which is located at the tip of the Dipper's handle. Ursa Major. Ursa Major constellation lies in the northern sky. Its name means the Great Bear or the Larger Bear in Latin. Ursa Major is the third largest constellation in the sky, occupying an area of 1,280 square degrees. It is located in the second quadrant of the northern hemisphere and can be seen at latitude between 90 degrees and negative 30 degrees. Let us discuss now the three circumpolar constellations in the southern circumpolar constellation. The three southern circumpolar constellations visible from most locations in the southern hemisphere are Carina, Centaurus, and Crux. The constellation Carina, the keel, is located in the southern hemisphere of the sky. Carina is the 34th largest constellation in the sky, occupying an area of 494 square degrees. It lies in the second quadrant of the southern hemisphere and can be seen at latitudes between positive 20 degrees and negative 90 degrees. The neighboring constellations are Centaurus, Chameleon, Musca, Pictor, Puppis, Vela, and Volans. Carina was once part of the larger constellation called Argo Navis. Centaurus constellation is located in the southern hemisphere. It is one of the largest constellations in the sky. It represents the centaur, the half-man, half-horse creature in Greek mythology. Centaurus is the 9th largest constellation in the sky, occupying an area of 1,060 square degrees. It lies in the third quadrant of the southern hemisphere and can be seen at latitude between positive 25 degrees and negative 90 degrees. Centaurus contains two of the top 10 brightest stars in the sky, Alpha Centauri and Beta Centauri. The famous blue planetary nebula, also known as the Zaudener, and Boomerang Nebula are also located in Centaurus. Next is Crux. Crux constellation means the cross in Latin or the Southern Cross. It is a prominent constellation in the southern sky. It is the smallest of all 88 constellations, occupying an area of only 68 square degrees. It is located in the third quadrant of the southern hemisphere and can be seen at latitude between positive 20 degrees and negative 90 degrees. The neighboring constellations are Centaurus and Musca. In tropical regions, Crux can be seen in the sky from April to June. Other constellations are just prominent in the sky and can be seen for most of the year, but only these 8 are circumpolar. Are you not asking why some constellation only visible at particular months? Why some constellation visible only during certain seasons? Have you ever noticed that the night sky in winter looks different than summer? This is what happens. We are surrounded by stars, but some are more special to us than others because Earth orbits in a flat plane around the Sun. We see the Sun against the same stars again and again at regular intervals. During the day, you cannot see stars. As the Earth rotates, you will rotate away from the Sun if you are not too far north or south. When you rotate far enough, it will be night and you will see stars. As the season change, you will see different stars because you will face a different direction at night. While the rotation of the Earth on its axis causes the apparent nightly movement of the stars across the sky, the revolution is responsible for the fact that we can see different parts of the sky at different parts of the years. An observer from Earth will be able to see the stars that are on the night side. The stars on the same side as Sun cannot be seen because sunlight overpowers all the stars' lights. The east to west daily motion of stars, planets, the moon and the sun are caused by the rotation of the Earth on its axis. The Earth and all the planets revolves around the Sun on circular orbits. This produces the change in constellation observed from one time of the year to the next. Here are some prominent constellations in the month of March, June, September, and December. During summer in the Philippines, the constellation of Orion and Taurus are not visible at night. They will be visible again as the cold seasons begin. During this time, Scorpius will not be seen in the night sky. The Earth revolves around its orbit. The stars that were concealed by the bright light of the sun in the previous month will appear in the night sky. Before I end this discussion, let us reflect on this. God's promises are like the stars. The darker the night, the brighter they shine. Have a blessed day, everyone. And thank you.
Thank you for bringing us to a galactic tour and mysterious world of constellation, Ma'am Nova. Before we proceed to our next speaker, may I remind everyone that at the end of this webinar, all participants are expected to answer the evaluation and assessment form to be posted on our screen at the end of all the discussion. And before we proceed with our third speaker, shout out po muna sa lahat ng teachers from Limay District, Pilar District, and Orion District. The Department of Education conducted different trainings and webinars that help us adapt to the new normal situation. Different approach and techniques are given priority, especially this time of pandemic, and how we are going to apply it on delivering quality education. And now, to help us become more effective and efficient teacher, our next speaker will equip us with the new teaching strategies that we can use for the topic weathering of rocks and soil formation. She is a graduate of Bachelor in Elementary Education, major in General Education, and a Teacher 3 of Colo Elementary School, Dinalupihan District. Let us all listen and be amazed to Ma'am Catherine Z. Lopez. Magandang buhay, Ma'am Catherine.
Good morning, science teachers! Good morning, everyone! Thank you for joining us live today. Well, I was tasked to give and share strategies suited as we present the topic of the most essential learning competencies for the quarter 4 under week 1, entitled Strategies in Teaching Weathering of Rocks and Soil Formation. For the content standard of this MEL, the learners demonstrate understanding of weathering and soil erosion shape the Earth's surface and affect living things and the environment. For the performance